Hello, this is going to be an introduction to trigonometry. Bit of a rhyme there. So trigonometry part 1. Okay, trigonometry. A few things need to know about it. What is it? What's the point of it? Well, we use trigonometry on right-angled triangles. We know from the Pythagoras video, we also use Pythagoras on right-angled triangles. This is going to be slightly different to Pythagoras because it looks like at angles in right-angled triangles, not just the side lengths. Okay. So it also looks at ratios between sides. So we're going to look at what that means, what that statement means. What does it mean for ratios between sides? Before we look at the ratios, we'll just start with some kind of terminology. It's important that you know some of the terminology for trigonometry. So we've got two examples here. We're labeling the points A, B and C. These questions will become clear in a second. Let me just write them all down. Okay. So, with example 1 then, you're going to be looking at the first question. Which side is the hypotenuse of that triangle drawn? Which side, the second question B is, which side is opposite angle C? And finally, for question C, which side is adjacent to angle C? Now, this is terminology. So, if we look at the hypotenuse, we know the hypotenuse is opposite the right angle. So, this is the hypotenuse. Okay? This is the hypotenuse. And we would say that the hypotenuse is side AC. That's the hypotenuse, that side A to C. The opposite angle to C, well, this is angle C, and opposite is this side. Which side is opposite angle C? Well, it's the side AB. Which side is adjacent to angle C? Well, there are two sides adjacent to angle C. There's this side here, or this side here. Now, we've already used the hypotenuse, and the hypotenuse never changes. So we say that that side which is adjacent to angle C is the bottom side there. This side here, which is side B, C. Continuing then, if we look at example 2, which side is the hypotenuse? So what you should really do is pause the video now and see if you can answer those 3 questions. So the hypotenuse then is opposite the right angle, it's the longest side, and that side is DF, D to F. Which side is opposite angle D? Well, the side that's opposite, if we draw an arrow, is that side there. So that's side EF. And finally, the side that's adjacent is this side here. Okay, it's this side just here, and that side is DE. Okay, that's just terminology. We need to know where sides are relative to angles. So we need to know when a side is opposite an angle, when it's adjacent to an angle, and which one is the hypotenuse. That's very important for trigonometry. Okay. Ratios. So we've got this triangle here, this 3, 4, 5 triangle, classic Pythagorean triple there, the 3, 4, 5 triangle. We've got this angle theta. So we're going to look at what that second bullet point means with regards to ratios. So this question says, the ratio for the sides opposite and adjacent to theta might be written as. Okay, so the ratio for the sides opposite and adjacent to theta. Which sides are they, first of all? So the side that is opposite theta is this side here, this side which has length 3. The side which is adjacent to theta is not the hypotenuse, it's this one here. So the ratio of the side opposite and the adjacent side to theta could be written as opposite divided by adjacent, the ratio, we would do a division here, the opposite divided by the adjacent, and that is just 3 divided by 4. Okay? 3 divided by 4. Similarly, the ratio for the opposite side to theta and the hypotenuse might be written as, well, we would write it as the opposite side divided by the hypotenuse. Hopefully you can see that's 3 divided by 5. So in trigonometry we're going to be looking at these ratios. And finally, the ratio for the adjacent side to theta and the hypotenuse might be written as the adjacent divided by the hypotenuse, which is 4 over 5. Now in trigonometry, these ratios have names. Now, we call the first ratio the tan of theta. The tan of theta is the opposite side divided by the adjacent side. This second ratio, the opposite side divided by the hypotenuse, is the sine of theta. And finally, the adjacent side divided by the hypotenuse is cos of theta. Now don't worry if you're not really understanding what I'm talking about too much. What I'm trying to do here is introduce terminology. So in this video, what I've tried to highlight is when a side is opposite an angle, when it's adjacent to an angle, and when you have the hypotenuse. So that's what I've looked at there on the left-hand side of this screen. Now on the right-hand side of the screen, when talking about ratios, I'm defining certain ratios. So I'm saying that the tan of theta, you take the opposite side to that angle and the adjacent side to that angle, and you just do a division. If I'm looking at the sine of theta, you take the opposite side to that angle and you divide it by the hypotenuse. And similarly for the cos of theta, you take the adjacent side of that angle and you divide it by the hypotenuse. This is all just terminology. We haven't really done any mathematics yet. In the next week, we'll be looking at trigonometry and some more interesting questions. This is just all definitions, trying to get you familiar with the language. And in Friday's lesson, we'll look at becoming more familiar with this language using some of the maths-based stuff. I've gone over 5 minutes. 7 minutes isn't too bad for a video. I'll see you on Friday.